Hello, everyone. Thanks so much for joining today. Welcome to the October edition of our Threat Detection Highlights webinar series. I am Ertuğrul Kara. I am Senior Product Marketing Manager at VMRay. And originally, my colleague, Thorsten Schreiber, was originally set to join us, but he couldn't make it. So Patrick is stepping in and is going to share some great insights on Latrodectus and more. Hello, Patrick.
Hello.
Great. So Patrick is a team lead in the threat analysis division of our labs team, and it's always great to see Patrick. And so, as always, this session is designed to give you a monthly scoop of on the latest and greatest at VMRay. We will keep it light, and since October is often associated with Halloween and all things, mysterious and spooky, it feels appropriate that we are taking a close look at a specific malware loader, which is Latrodectus, and we are seeing more of it lately. And just as a quick note, this session is being recorded, and we'll share that with you afterwards. Plus, all the analysis reports we will be looking at today will be available on our community thread feed portal. So you will have plenty of time to review everything after we are done. So together with Patrick, here is what we will be covering in our short, 30 minutes together today. We are here to talk about what's new in our VTIs, so VMRay threat identifiers, as you know, probably the acronym. Some fresh YARA rules we have added recently, and of course, a cool demo on extracting malware configurations for Latrodectus loader. And just a quick reminder, feel free to type in any questions. I'm underlining any questions as we go. We will make sure to cover them all at the end. So let's look at our first VTI. This is around the changes in Windows registry to disable Defender notifications. Actually, Azure stealer was observed to be taking this type of action, although it's not so popular these days. But latest operation just yesterday to Redline and Meta stealers maybe would let us see more activities around Azure. So it's good to keep an eye on this one. And anyways, this type of behavior aligns with the defense evasion tactic under MITRE. And basically, here the malware uses these registry modifications to stop Windows Defender, which is one of the most common, if not all, available in all desktop devices. So from alerting users or administrators. And the VTI gives us a quick sense of how concerning a specific behavior is, as you know, and a high score indicates it's likely associated with evasive or stealthy malware actions. And on our side, we scored this behavior with a VTI 4 out of 5. And since, interfering with Defender notifications is a clear attempt to hide malicious activity, and it ranks, that's why it ranks quite high. Now, as we move to the next slide, you will see a similar tactic, still aiming to disable notifications, but with a slightly different approach. So here is another notification-based tactic. This time, the malware is targeting Windows Security Center notifications, to keep us in the dark, and is turning off important update alerts, software update alerts, which could leave an endpoint vulnerable without immediate visibility into the issues. And again, we are in the defense evasion category, and this again has been given a VTI score 4 out of 5. Similar to the previous detection, disabling these notifications is a significant red flag for us. And these notifications are, it's kind of the frontline warnings. So if they are suppressed somehow, it's much easier for malware to operate undetected. And the consistency of VTI scores here shows that any suppression of alerts or notifications is taken seriously in our evaluation process. So right now, let's shift gears from notifications to something less common, but equally, again, something to highlight. So this detection focuses on run DLL 32 exe and executing DLLs from a network drive instead of a local path, and which is somewhat unusual and can signal a potential, again, a defense evasion attempt. And here the VTI score is, as you can see, 2 out of 5. And while loading DLLs from a network drive isn't really inherently malicious, it's uncommon. So we would like to flag it. And the network interaction happens behind the scenes, and we didn't want that. So this behavior can be used in attacks where the malware tries to stay under the radar, of course, by using legitimate system processes. And this lower score reflects that it is worth monitoring, especially if it escalates or is seen alongside other suspicious behavior. And actually, this was kind of reported by one of our customers. And for this specific sample, it turns out the second interesting behavior was that the DLL checks the keyboard layout and only proceeds with the malicious behavior if it is in the specific language of the target country. So that was something interesting. And now, we added this VTI, and we are on to the last VTI of today. And this is another one. So here, what we see is the malware would like to access Thunderbird profile, including some sensitive data, which is, of course, one of which is credentials. Again, this is not inherently malicious, but it's worth monitoring. And actually, I would like to share how it looks like on a real report. So I'm going to share with you right now an analysis report on this. So, but before that, here is the one around Windows Defender notifications. So we see here an executable, and as you can see, I mean, this is the high score. We see it on top. So it's disabling the Windows Defender notifications. And what I would like to show you here, it's just a quick showcase on how it looks like. So when you look at the IOCs, actually, it's not only the IP addresses, domains, but there are other categories of artifacts here. One of them is registry keys. And here you can see that the registry key and the malware clearly wanted to change it so that to disable the notifications. And coming back to the Thunderbird, so here is another sample named as Isabella Trump something. So we classified this as injector. And here, as you go down to to see all the VTIs, so we see here some high score VTIs, like writing into the memory of another process, or also we call it with reputation as well. But here there's the one that we were looking to have, which is accessing the Mozilla Thunderbird profile data. And if you would like to have more information around this, I mean, there are a lot of things going on, but you can see here clearly the behavior and how we were able to catch this. So this is now available as a VTI. So from now, I will come back to my presentation. Do I share the right screen, Patrick? Just to confirm.
We do see the presentation again, yes.
Perfect. All right, so just a quick moment after all these VTIs to highlight the value. And I mean, we have been looking at VTIs typically in the context of detections, but there is actually some other value here, some extra value here from malware analysis perspective. And one big advantage is that, and hope you like the meme here. So instead of spending hours, manually documenting every suspicious action in the malware's code, you get an organized list of behaviors, as I just shared with you, right in front of you, and it saves time. So that's a win for us. And this doesn't just benefit, the seasoned malware analysts. So VTIs are also a huge asset for junior analysts who might not be as specialized in malware. So to get a clear view into potentially malicious behaviors, like we just went through some of them. So this can give newer analysts a head start. So this is kind of all good stuff. So I just wanted to highlight it again. So right now we will move on to the YARA rules. And first up is a rule targeting anti-debugging techniques from the Al-Qaja project. Maybe some of you are aware of this one. So this is specifically focusing on unusual use of the virtual alloc API. And as you may know, Al-Qaja is a well-known open source collection of evasion techniques and also known to be used by malware. And interestingly, it's also being observed in campaigns involving Bumblebee. So there is some crossover with active malware families. And right now, actually, I would like to hand it over to my colleague, Patrick, who can give us a bit more background on the connection between, Bumblebee and this Al-Qaja project. Patrick, maybe a couple of comments, or would you like to share some insights?
Of course, yeah, thank you. So maybe just a couple of facts to highlight here, because we are explicitly targeting one of the techniques that are being implemented in the Al-Qaja project. And in the past, as Ertuğrul already mentioned, it also has been used by other malware families. We have deeply analyzed a loader which is called Bumblebee. Probably all of you are familiar with this one. And the developers behind this family were actually quite lazy. So instead of just thinking of what can we implement to detect sandboxes and try to avoid being analyzed, instead of putting lots of effort into figuring out these ways, they just did their research, right? Whatever, usually researchers are going to do. And they probably just came across the Al-Qaja project on GitHub, which, as Ertuğrul mentioned, is just a huge collection of evasion techniques that are either have been already seen in malware in the past, whereas, most of them are real evasion techniques that have been seen, and some of them are more or less theoretical techniques on how you can detect the sandbox. And they just took all of this code that is already there and copied it into their own development. And voila, with a couple of minutes, they basically have a huge collection of evasion techniques implemented in Bumblebee. And maybe two more side effects that we have for Bumblebee, and maybe you have heard of this, but Bumblebee was part of the Operation Endgame that happened, I think, earlier this year. The botnet and the operations basically were just shut down, and in the end it died. So we haven't seen any activity since then happening for Bumblebee. However, an interesting observation has been made, I think a couple of days ago, maybe a week ago, and new samples from Bumblebee have reappeared again. So even though they were shut down, it looks like they have slowly restarted operations, and now they're starting to distribute and spam samples again around, which of course on one side shows the effectiveness of a takedown. It got interrupted for a couple of times, but unfortunately, of course, there's always the risk left that those families are reappearing again. And at least the good news so far, there hasn't been any major changes that we have seen. So they may be still adjusting a bit in the delivery chains, but overall the detections that worked previously seem to still work pretty well on the most recent Bumblebee samples that we have seen a couple of days ago. With that being said, Ertuğrul, I will pass it back to you.
Yeah, great insights, Patrick. I mean, there's definitely a risk of comeback, right, when it comes to these operations in the malware families. So, all right, so let's move on to our next, what we did around the YARA rules. We have a rule around detecting malware that tries to evade Windows Defender's AV emulator by checking for God files. So maybe this is not so familiar for most of you guys, but for anyone interested in learning more, there's an excellent black hat presentation called Reverse Engineering Windows Defender AV Emulator. And it's also linked in our resources that dives deep into how these code files are used. And essentially, these files are harmless placeholders used to create a typical Windows environment. But some malware now looks for them to detect if it is in a sandbox or if it is getting analyzed. So our rule kind of catches this type of behavior to ensure we don't lose visibility to this type of action. And finally, we added 3 rules to detect different phish kits. So there is no shortage of phish kits. And the first PhishKit.MSDoc detects phishing pages that imitate Microsoft Office documents. And the second, very quickly, PhishKit.JSSlice focuses on kits using JavaScript slicing techniques. For those curious, the term JSSlice actually comes from a variable name found in the phishing landing page JavaScript code. And lastly, the EDG one, that's kind of identifies the kits designed to mimic email provider login pages. So these often come with pre-filled email addresses and recognizable icons like Gmail's favicon, for example, making them look even more authentic to the users. So thanks for sticking with me. And now I'm going to hand things over to Patrick for a quick walkthrough. He's going to spend around 20 minutes diving into Latrodectus and how its config extraction looks like. So Patrick's team, just a quick note, has also done some fantastic work on other malware families, like the one that he just mentioned, Bumblebee. I'm sure many of you are familiar with Bumblebee, or it can also another malware, Picabot. So I would like to say we are in very, very good hands. So yeah, over to you, Patrick.
Okay, yeah, thank you. Let's dive into Latrodectus, and maybe Arthur, you can enhance the slides for me to look into them. Thank you. So first of all, I mean, what is Latrodectus? It's basically a loader that has been around now for basically a year or a bit more than a year. And it seems to have some very interesting connections to the famous iced-ID loader, which is in fact just another family that was part of the Operation Endgame's takedown. And since then, basically, or maybe even a bit earlier, we have seen that Latrodectus appeared in the threat landscape. We have explicitly called this an evolving loader because we have seen, since it has been around in the wild, a couple of changes, and actually those changes seem to get more and more frequent. But let's first of all focus on some of the key facts that we have seen with Latrodectus. First of all, the delivery chain that is being used by these threat actors for this family seem to be quite constant. So in this case, we have mainly seen some JavaScript files that are going to drop MSI installers, which then are going to finally drop and execute the DLL, which is the core payload of Latrodectus. This, I think, is quite an interesting observation because at least in the current threat landscape, especially since Microsoft blocked the execution of macros per default that are coming from untrusted sources a couple of, well, I think it's close to be 2 years ago already, a lot of threat actors started to explore different ways on how to deliver their payloads, right? We see quite a lot of different file types, we see different techniques. And even though within the same threat actor and the same family, those are going to change quite frequent. However, for Latrodectus instead, they usually seem to stick with the same type of delivery for quite some time already. Since a couple of versions back, we have also seen that they adjusted the encryption logic that they have used to encrypt their embedded strings, but we will cover this a bit later. And also due to some recent development, maybe restructuring that they're going through, we have also seen that the C2 endpoint that is being used to contact the C2 server has also started to change. Can you also please, yeah, thank you. That's awesome. So we basically have seen Latrodectus now for a year, and we are monitoring and tracking it for a couple of months now. And we have tried to come up here with a timeline. So the first version of Latrodectus we have seen is from September 2023. which was version 1. And then we basically started to collect all the different versions up until now. And the interesting observation here is that, I mean, now we're talking about 1 year, right? And we have seen quite a lot of different versions already. And the most interesting change, although, is that between version 1.4 and version 1.5, you basically see only a time delay of a bit more than 1 day, right? And again, from version 1.7 and version 1.8, you see like close to 10 days, right? This is quite an interesting observation because usually, I mean, they are building their own malware and then they basically release it, kind of, whatever software vendors are doing as well. But they're also re-releasing it like in a very short amount of time later on, which is an interesting observation, quite unusual from our point of view, but still could also highlight that they maybe made some issues, some mistakes, or wanted to add some improvements that they just came across. So overall, basically, the trend that we see is in the most recent weeks or months, we have seen that the time duration until their releases seems to get shorter and shorter. And of course, as usual in malware families are trying to do, they want to evade sandboxes to avoid being analyzed and so they can operate as stealthy as possible for as long as possible. So for Latrodectus, we have also seen a couple of different evasion techniques, whereas the origin of some of them is not 100% clear to us currently because they are usually not really effective at all. However, the most relevant one that we want to highlight here today is the very first one, which is about the process count check. So essentially, you all know that whenever you're using a real world system, like your notebook, like your corporate device, there are a bunch of processes running on this machine because you usually have Outlook open, you have other processes like Internet Explorer or Chrome, whatever you're going to use, messaging applications, and so forth. So there are quite a bunch of different processes running. Whereas usually in sandbox systems, to analyze the files, there's not really any additional software running because the only goal that we have is we want to analyze the sample, but we don't really want to use this machine, right? So the developers behind Latrodectus added this process count check, which just counts the number of processes that are being running. And whenever it's below a certain threshold, they are just terminating and try to hide their malicious behavior. And of course, thanks to the effort that we're putting into this and the evasion resistance of VMRay platform, this of course is not really a problem because we are running sort of these fake processes in the background to mimic our environment looks as much or as legitimate as possible. So this is not really any kind of problem. Well, as mentioned, there are other checks like MAC address validation. They are, of course, checking for debuggers and also if they are basically being executed through the WW64 Windows subsystem. Then when we move on to the next slide, we are going to talk about Latrodectus string encryption or string decryption. So essentially, for a threat analyst, reverse engineer, it's very important to basically understand the internals of a certain malware family. And just by looking into strings, they're already telling you quite a lot of information. Yeah, you probably know maybe some API names that are being present there, maybe some arguments that are used. So strings really indicate already quite a lot on the capabilities of the sample. So it's essential for threat analysts to understand this, but of course it's also very, very important for malware configuration extraction to basically have this plaintext strings. For Latrodectus, we have seen quite a couple of different string encryption implementations that they had. So while they initially started with a simple XOR operation and they just used the pseudo random number generator to seed this basically, they quite shortly replaced this by a rolling XOR where they just used a basic incrementing counter for their seed. And in the most recent version, starting with 1.4, which is a couple of months old now, they basically replaced this whole encryption logic with AES 256. And this was also one of the major changes that we have seen so far in Latrodectus. And this is, of course, still valid to be used up until now. Well, now I think it's time that we indeed dive into the actual interesting and relevant parts of this webinar, basically. And this is a quick demonstration on how our most recent changes look like in our analysis report. So what we're going to look here now is into a VMRay analysis report. We have here a dynamic analysis of a Latrodectus sample. And even though I guess majority of the audience is already familiar with our reports, I just really like to recover those basic things to also catch up people that are not really familiar with our report yet. So when looking into this report, you immediately see that this is being flagged as a malicious sample, right? So all of the behavior that is being operated, being done by the sample is being classified to be malicious. We can also see it gets added this downloader classification. So Latrodectus is supposed to download second stage payloads or next stage payloads. So we also properly flagged this one here. And we can see the threat names. Well, in this case, it's easy. We already know we're talking about Latrodectus, but of course, if you have an unknown sample, then this is very valuable and adds a lot of information for you. And we also have a specific threat name here because we know it's version 1.4 of Latrodectus. If we go down here to the core part of the report, we can see our VMRay threat identifiers, or in short, VTIs. And AirTrue already covered them before, so it's basically just a scoring system we use to determine whether the behavior of a sample is malicious or it's not, right? But on the other side, as it's triggering on dynamic behavior that we observe during the execution of the sample, it also already tells you a story on the capabilities of a certain sample. So every category and operation we have here are describing a certain behavior that we observe during the execution, which already tells you really a lot of internal information on what the sample is capable about and what it can do and what it actually does, even without opening it in any reverse engineering applications or whatsoever. You really get a lot of information just by looking into this report. If you go down here, we also see the malware configuration extraction, which I will just cover in a second, and also a process tree and the MITRE attack matrix mapping that we have here, some more metadata. And maybe to highlight, all of this information is just extracted out of the sample in an analysis of 2 minutes, right? So just waiting for 2 minutes and you get all of these results. However, what is new and what have we introduced in the past month? Actually, I will also go a bit more back because the YARA rules that we have introduced for Latrodectus are already from the previous month. And this month, we basically catched up also with the malware configuration extraction for this family. So we can see here quite a lot of YARA matches on the sample itself somewhere. We have YARA matches against some memory dumps, and even a specific YARA match that indicates this is version 1.4. Then we also, as mentioned, have the Latrodectus malware configuration extraction. And if we go down over here, we can see that we are putting out the most valuable and most useful information out of the sample. So first of all, of course, we have its command and control server URLs, which are respectively also gets added as an IOC to this analysis that can be used for further processing, threat intelligence, and even threat hunting. We extract the version of it. So in this case, it's a sample from version 1.4. We even have the mission IDs that are being basically listed here as well. And then, of course, we have 2 different encryption keys, whereas one of them is used in encrypting the network traffic, and the other one is being used to encrypt the embedded strings. And this is, as mentioned, visible here in the analysis report, but of course, it's also being dropped as a JSON file for further processing if you want to use it. And there's one more thing that I would like to highlight today, which is very juicy information that we haven't shared yet, and it's actually also being part of the blog post that we'll put out in the future. But as we're now looking into this and we explicitly talk about Latrodectus, I'm really happy to basically share this with you already today. Within Latrodectus, we have seen one very interesting technique that is being used to delete the sample after it got executed. And this is a very interesting way because usually that makes post-analysis, post-execution analysis way more difficult, right? So considering you're having an incident or whatever, and you basically take the disk image and you need to do some forensic investigation, the sample might be no longer on the disk anymore, even though the process is still running in the background. So if you capture the memory, you can still basically get a lot of information out of this, but the sample itself is gone. And this is done via a specific technique that uses the alternate data streams of Windows. And we have introduced a new dedicated VTI to detect this behavior. So the sample itself makes use of renaming the main alternate data stream of this file to something which is called :WTF BBQ with a so-called deletion disposition. And this essentially means that in the combination with a couple of API calls in the background, which of course we won't cover here because that's usually quite technical internal stuff, but with a specific combination of those API calls in the background, the sample itself manages to set the specific deletion disposition flag. And then once it's basically during its execution and when setting this flag, basically, Windows automatically picks up this file because it's being flagged for deletion and removes it from the file system, even though it's a protected file because it's currently being executed as a process, right? And this is a very interesting behavior that we haven't seen before. Latrodectus actually had this implemented. There's also already somewhere a proof of concept out of this for this technique. But we think it's very interesting to highlight and very interesting to show because this is a very stealthy way to basically hide the sample itself from doing forensic investigations. With that being said, I think that's at least the most relevant part that we want to cover here. And I would like to pass the mic back to Ertu.
Thank you, Patrick. Let me pull up my slides again. All right. So, I mean, great insights and fantastic walkthrough. And that's definitely interesting about that self-deletion using alternate data stream, and we observe it only with Latrodectus. That was great. So before we wrap up, the resources we have put together here, and you will find links to everything we covered today, and including the public analysis reports as we promised. And yeah, I mean, that brings us to the end of today's session. And thanks so much for joining us. We are now going to open it up for Q&A. So feel free to drop your questions in the chat. And we will get to as many as we can. And just a few quick notes before we wrap up. First, there will be a November edition next month. And so keep an eye out for that one. And also, we will be sharing today's recording shortly, so you can review anything you might have missed. And if you would like to try out VMRay, we are offering an extended 3 months free trial. So with the code you see on the screen, so feel free to take advantage of that. So now let's check out the questions. So I think some questions for Patrick. Can you share how VMRay manages to analyze malware with encryption? And how does it work around encrypted payloads that Latrodectus or other loaders might be using?
Yeah, of course, I'm happy to take this over. So basically, the good news on the approach that we are doing with having a analysis environment, a sandbox that's dynamically executing all of the files that you basically detonate. The good thing about this is that we basically usually don't really have to care about encryption at all, right? So there is not really a huge difference between detonating a sample on your real machine compared to the sandbox, right? So we just execute a sample and the sample itself is doing the decryption for us. So we don't really need to take care of decrypting any stuff. However, we do have specific trigger reasons defined that are causing a memory dump, right? So that's essentially during the execution, when we see certain behavior, we are taking specific parts of the process's execution memory and extract it for later processing, right? So considering a case where maybe a loader like Latrodectus would download an encrypted payload, right? And it would decrypt it internally because at a specific point of execution, it has to be decrypted, and the sandbox, essentially the loader itself, is doing this for us. And at a specific time when this has happened, due to the smart memory dumping trigger reasons we have, we basically fire a memory dump, which just takes this memory region that contains the decrypted payload, and then we can extract it and further process it. This is essentially important for being effective and efficient in malware configuration extraction, because we can take already the decrypted payload out of the analysis and don't have to implement all of the decryption logic by ourselves, right? So that's the advantage of the sandbox and dynamic analysis, that we don't really have to consider the encryption because the sample itself is doing the decryption for us.
Amazing. Another one, Patrick, this is for you as well. Can you talk about how flexible VMRay is with custom YARA rules? Are we able to add our own rules? Yeah, to catch new threats and specific behaviors?
Yes, of course. So VMRay provides you a default set of YARA rules that is maintained by the labs team. So due to our research, what we have also showed here, we basically also, of course, maintain and add new YARA rules on a regular basis. However, also for all of our customers, either on-prem or in cloud, it's possible to add your own YARA rule sets. So you basically just have to write them, and you can upload them either via API or via the console. And there's even one more advantage that we have here. So for our YARA rules, we also use specific variables that are also documented in our documentation, basically, that allows you to only match against specific file types of an analysis, right? So this could either be a memory dump, a sample itself, that could be function strings or whatever, right? Or web requests, for example. So you have the ability to add your own YARA rules, of course, but you can even extend them with some VMRay specific detection logics that we have added there.
Perfect. Thank you, everyone, for questions, and thanks, Patrick. So lastly, happy Halloween to all who celebrate, and thanks again for tuning in.